In this lesson, we're going to identify linear functions. All right, so let's first of all talk about the characteristics of a linear function. A linear function has a constant rate of change. And so what that looks like on the graph is it's going to be in a straight line. And it could be a positive slope, it could be in a negative slope. That does not matter. It just has to be in a straight line. In order to tell if a graph is, or a table is linear, we need to check to see the change in the y out of the change in the x to see if it's constant. So notice how we're going up 2 in our y, we're going up 2, and we're going up 2. In our x's, we're going up 1, and up 1. So our rate of change here is 2 all over 1. It's the change in the y all over the change in the x. Notice how they're constant. You're going up 2 for every 1 you're going over. All right, in an equation, for it to be linear, it can be written in the form y is equal to mx plus b. The m represents our slope, and the b, and we're going to learn about this a little bit more in our next lesson, is the y-intercept. And so let's go ahead and we're just going to highlight this. So if it can be written in the form y is equal to mx plus b, it then is linear. And so some examples of that would be y is equal to maybe 2x plus 1. You could have it written something like y is equal to x all over 4 minus 3. You can have an x on the top of a fraction to be linear, but you cannot have it on the bottom. And another form that it could be written in would be in what we call standard form, which could be something like 4x plus 2y is equal to 10, because I could rearrange this equation and solve for y, and therefore it would be in that form y is equal to mx plus b. Now, for it to be direct variation, what that means is that it is a proportional relationship, and you learned a little bit about that last year. All right, and so to be proportional or to show direct variation, on the graph, it is going to go through the origin, and it has to be in a straight line. It could be a positive slope, it could be a negative slope. But the idea is that it's a straight line that goes through the origin that makes the graph direct variation or proportional. Now, when we have the constant rate of change, notice how I'm going up 3, I'm going up 3, and I'm going up 3. And then our x's were going up 1. So it's got that constant rate of change, and that's what makes it linear. Now, what makes this proportional is that it is going through the origin, it's going through the 0, 0. All right, and so direct variation equations or graphs or tables, they are linear. It's just that they're a little bit more specific in the fact that it goes through the origin. And so now if we're looking at then our equation for a direct variation is in the form y is equal to kx. This is the constant of variation. It's like our slope. And one of the things that I want you to then also notice is that another way you could kind of write this is y is equal to mx plus 0, because it's going through the origin at that y-intercept. And so, but instead for direct variation equations, we use that variable k. And so writing our equations, you could have something like y is equal to 2x, because 2x then it would be plus 0, or you could have something like y is equal to x all over, let's say, 4, all right? Because again, the y-intercept ends up being the 0. All right, so let's go ahead and take a look then at these nonlinear functions. A nonlinear function, it's not going to be in a straight line, so it could be something like this. It could even be something like this, because when we have it in a straight line, it has to be in a continuous straight line. So these would both be considered nonlinear, even though you've got part of it is in a straight line. So let's go ahead and take a look at our table for a nonlinear. I'm going up 4, I'm going up 1, I'm going up 3. Now, the x's are going up just by 1s. But notice how you have 4, 1, 3. The rate of change is not constant. That's what makes it nonlinear. Now, as far as equations, you will have equations if your equation has an x squared or x third or any of those. If your equation has one of those in there, it's not linear. If you have like a y squared or y to the third or y to the fifth, those are nonlinear. If you have a square root of a variable, or another one that's important for you to know is that if the x goes to the bottom of a fraction, that is going to be nonlinear. Example 1, how do I determine if a relationship is linear? So we're going to determine if the graph is linear, and then if it is, we're going to find the rate of change, and then also determine if it's directly proportional. So our first graph here, notice how it's not in a straight line. So no, this is not linear. Our second line, notice how we do have a straight line, so this is linear. So let's find the rate of change. Remember, to find the rate of change, we're going to identify 2 points and then go do the rise all of the run. So it went up 1 and we went over 3. So the slope of this is 1/3. Now, this is not directly proportional, because if it was directly proportional, it would have started at the origin. And because this has a y-intercept of -1, this is linear but not directly proportional. Our next graph, notice it is linear as well. And then let's find the rate of change. So I'm going to take these 2 points and I'm going up. Now notice how these are going up by 20s. So I'm going up 120 and then I'm going over 5. And so our slope is 24. And then also notice that it is going through the origin. It started at the 0, 0. So this is directly proportional. Oh, let's just put proportional here. So now let's determine if our tables are linear or nonlinear. So let's go ahead and let's find the rate of change here. Remember, it's a change in the y out of the change in the x. So we are going down 4, and then we're coming up 5 in the x. We're going down 4, and then we're going up 5. And then again, we're going down 4, and then up 5. And so we've got that constant rate of change. It has a slope of -4, change in the y out of the change in the x. So yes, this is linear. Now, also note that this has at the 0, that's our y-intercept, and this has a y-intercept of 20, and therefore this is linear, but it is not directly proportional. If it were directly proportional, it would start at the 0, 0. All right, let's take a look at our next one. And again, it's a change in the y, all over the change in the x. So we're going up 2, and we're going up 2. We're going up 4, and then we're going up 2. We're going up 10, and then we're going up 2. If you were to simplify all of these, the change in the y of the change in the x, the first one you'd have would be equal to 1. We take 4 divided by 2 would be 2, and then 10 divided by 2 would be 6. And so because this has different rate of change, it does not have a constant rate of change, no, this is not linear. All right, and our last one here, let's go ahead and we're going to then find the change in the y, all of the change in the x. It went up 1, and it goes up 3. It goes up 1, and then goes up 3. And so our rate of change here, the change in the y all over the change in the x, our slope here is 1 all over 3. It is a constant rate of change. And so therefore, yes, this is linear. Now let's take a look then to see if the linear function is directly proportional. And notice that at the y-intercept, at 0, it goes through 0, 0, which is the origin. And so then that makes that directly proportional. So let's just indicate that it's proportional. All right, so now we're going to take a look at these equations and we're going to determine if these are linear or nonlinear. And then if they're linear, we're going to determine if they are directly proportional. So let's go ahead and take a look. Remember that for an equation to be linear, it has to be able to go in the form y is equal to mx plus b. And so let's take a look at the first one. We have for letter G, y is equal to negative 3x plus 3. Well, this is in the form y is equal to mx plus b, so this one is linear. For letter H, we have y is equal to x squared plus 4. Now, you might have remembered in the first slide that we were talking about that what makes something nonlinear is if you've got something that is an x squared or a square root, that is going to make it nonlinear. All right, for letter I, we have y is equal to 3 all over x plus 6. And so also remember in our, when we were talking about the linear versus nonlinear, we said that if the x ever is at the bottom of an equation, or I'm sorry, the bottom of a fraction, that is going to make it nonlinear. So this equation right here is nonlinear. All right, letter J. We have y is equal to 4x. Now, notice how we've got the 4x, and if there's not a number there, you could essentially say that there is a plus 0. So, and remember, to be direct variation, it's when it goes through the origin that the y-intercept is 0, 0. And so this here is linear, but it's also directly proportional. All right, for letter K, we have 4x plus 5y is equal to 20. Now, let's go ahead and let's get our y all by itself so that we can determine if it can be put into the form, the slope-intercept form. So I'm going to solve for y by minusing my 4x on both sides, and I'll have 5y is equal to 20 minus 4x. And then we're going to divide by 5 on both sides, so now y is all by itself. And we'll have 20 divided by 5 is 4, and then you can't divide 4 divided by 5 evenly, so you're going to just have the fraction negative 4 all over 5 for the slope x. And notice that this is in the y is equal to mx plus b form, and so this is linear. All right, so for letter I, we have, or L, we have x times y is equal to 8. For this one, let's go ahead again and let's get the y all by itself. And since that x is multiplying the y, let's divide both sides by x so we can isolate the y. So y is equal to 8 all over x. Now remember that we said that if the x ever goes to the bottom of a fraction, that makes it then nonlinear.